Welcome to the void. It's cold, it's empty, and statistically speaking, it is actively plotting your demise. But enough with the pleasantries. Let's talk about how your Tuesday is about to be ruined. Imagine you're scrolling through your phone, ignoring your responsibilities. When the news drops, astronomers just spotted a rock the size of a football stadium. It's not waving hello, it's screaming toward Earth at 30,000 miles per hour, and it's going to punch a hole in the atmosphere exactly 2 weeks from today. The impact energy? Roughly 4,000 Hiroshima bombs detonating simultaneously. If it hits land, goodbye city. If it hits water, goodbye coastline. This isn't a movie script. This is basic orbital mechanics. And frankly, the universe doesn't care about your plans for the weekend. Now, before you roll your eyes and say, this is science fiction fear-mongering, let me introduce you to two very real, very terrifying friends of ours. Asteroid 2019 OK and Asteroid 2019 MK. These weren't hypothetical simulations, these were city killers. And do you know when NASA spotted 2019 OK? Less than 24 hours before it buzzed past us, closer than our own weather satellites. It was a sniper shot from the dark that missed by a cosmic hair. If that rock had been on a collision course, you wouldn't be watching this video. You'd be ash. So, the threat is real, the timeline is short, and our current options? They are laughably bad. Let's look at the standard deflection playbook. Usually scientists talk about gentle nudges. We could paint one side of the asteroid white so the pressure of sunlight slowly pushes it off course. We could strap ion thrusters to it. We could use massive lasers to vaporize a spot on the surface to create a jet of gas. These are elegant, intelligent solutions. They are also completely useless if you only have 2 weeks. Those methods take years, sometimes decades, to change an orbit. Trying to stop a stadium-sized rock hitting us in 14 days with a laser or some white paint is physically equivalent to trying to deflect a fully loaded cargo ship by throwing a bag of potatoes at it. It's cute, but you're still going to get crushed. So why is this so hard? Because we misunderstand the enemy. In movies, asteroids are solid, monolithic mountains of iron and rock, indestructible. In reality, most asteroids are just cosmic trash bags. They are what we call rubble piles. They aren't solid, they are loose collections of gravel, dust, and boulders held together by nothing but their own weak gravity. If you touch them too hard, they don't break, they swallow you. They act like a fluid. Trying to push a rubble pile is like trying to push a wave. It absorbs the energy, shifts around, and keeps coming. This brings us to the American approach, the Michael Bay solution. Why don't we just shoot a nuke at it? We have thousands of them gathering dust, right? Here is why that is a suicide mission. First, the intercept speed. If we launch a rocket to meet this rock, the closing speed is roughly 70,000 kilometers per hour. That is hypersonic insanity. If your nuke hits the asteroid head-on, the electronic brain of the bomb will be physically pulverized into plasma nanoseconds before it can even trigger the detonation. You just threw a very expensive dude at the apocalypse. But let's say you solve the timing. You detonate the nuke a few hundred meters away. In Hollywood, there's a massive fireball and a shockwave that knocks the asteroid off course. But Hollywood has air, space does not. Without an atmosphere, there is no medium to carry a shockwave. A nuclear explosion in space is just a really bright flash of X-rays and heat. It's silent. There is no push. It would be like throwing a washing machine at that cargo ship instead of the bag of potatoes. It's heavier, sure, but the ship isn't moving. And don't even get me started on the drilling idea. Landing a crew on a rotating, low-gravity rubble pile to drill a hole? That's not a plan. That's a slow, agonizing funeral procession. We need to stop thinking like miners and start thinking like lumberjacks. If you want to split a log, you don't burn it, you use an axe. We need a kinetic solution that uses the asteroid's own speed against it. Enter the Penetrator. This isn't a bomb. It isn't a complex robot. It is terrifyingly simple. It's a long, thin, incredibly dense rod of tungsten. A metal so heavy, a small cube of it weighs as much as an unsuspecting hatchback. We don't launch this at the asteroid. We launch it into the asteroid's path. We deploy this tungsten needle and just let it float there, perfectly still, waiting in the dark. The asteroid is the one doing the work. It's rushing toward us at hypersonic velocities. It doesn't see the needle. When that 100-meter rubble pile hits the stationary tungsten rod at 70,000 kilometers per hour, physics takes the wheel. The rod doesn't just poke a hole. At those speeds, solid matter acts like liquid. The tungsten penetrates deep into the core of the asteroid instantly, transferring all that kinetic energy into the center of the rock. It's called hydrodynamic shock. The energy release is instantaneous and catastrophic. It superheats the rock from the inside out, vaporizing the core in a fraction of a second. The pressure spikes, and the asteroid doesn't just crack, it unzips. The rubble pile is blasted apart from the inside, scattering into a million harmless pebbles. Instead of a single stadium-sized bullet hitting Earth, the atmosphere is peppered with a shotgun blast of gravel. It burns up upon entry. The apocalypse is cancelled and replaced with the greatest light show in human history. We turn a city killer into a harmless meteor shower. Sounds perfect, right? A clean, physics-based win for humanity. But there is a massive, glaring problem we haven't discussed. The method I just described works on the small stuff, the city killers, the pebbles. But out there in the deep dark, lurking in the shadows of Jupiter, are the monsters, the planet killers. The mountains of iron and death that don't just erase a city, they reset the evolutionary clock. The dinosaurs could tell us all about them if they weren't currently fueling our cars. But those city killers are just cute little pebbles compared to the true endgame boss of the solar system, the planet killer. We aren't talking about a dense rock anymore. We are talking about a long-period comet. Imagine a mountain-sized dirty ice ball, darker than a nihilist's poetry journal, falling from the outer edges of the solar system. It's not tumbling, it's screaming toward us at 140,000 kilometers per hour. Remember Comet Neowise? Beautiful, right? Now imagine Neowise decides it hates your real estate value and slams into the Pacific Ocean. At this speed, interception is a nightmare. The math is absolutely horrifying. If we try to use the kinetic impactor method we just talked about, slamming a ship into it to nudge it off course, physics just laughs in our face. The comet is too heavy and moving too fast. To generate enough energy to push this beast away from Earth, we wouldn't need one rocket. We would need 24,000 super heavy launch vehicles. Humanity currently has, let me check my notes, 2. And one of them is usually in the shop. We don't have the armada. We don't have the time. If this thing appears on the radar, simply trying to push it means we are mathematically, statistically, and spiritually screwed. So we stop trying to be gentle. We stop trying to nudge. We go for the kill. We need a plan that sounds like it was written by a pyromaniac in a fever dream. We need the hybrid interceptor. We aren't just sending a nuke, we are sending a drilling rig made of apocalypse. Here's the logistics of the end of the world. We take a single NASA SLS rocket, the big boy, and we strip it of everything that isn't essential. No snacks, no science experiments, just pure, unadulterated propulsion and a payload of death. On top, we stack a hyper-specialized vehicle carrying 5 independent kinetic penetrators. But here is the tragic catch. Computers are fast, but at a closing speed of 140,000 kilometers per hour, light lag is a killer. We need human intuition on the stick for the final approach. We launch a crew, a few brave souls who look at a one-way ticket to the void and say, let's light this candle. They spend 5 months traveling past Mars into the deep dark, knowing they aren't coming home. They are the guidance system. Now, slow everything down. Way down. The moment of truth isn't a bang. It's a sequence of precise, violent engineering miracles occurring in the blink of an eye. The interceptor separates. The astronauts sign off. The target is a wall of black ice filling the entire sky. The first penetrator slams into the comet. We are talking about a tungsten rod hitting ice at Mach 100. It doesn't splash, it liquefies. The kinetic energy is so high that the rock and ice behave like soup. The tungsten vaporizes instantly, but its momentum punches a hole into the crust. It's not an explosion, it's a spear of pure heat. Milliseconds later, literally while the debris from the first hit is still expanding, the second penetrator threads the needle. It flies right into the crater caused by the first one, smashing into the bottom and digging deeper. Then the third, then the fourth. It is a jackhammer from the gods, violently smashing and melting a tunnel 100 meters deep into the heart of the comet in a fraction of a second. We are forcing a path into the mountain's ribcage, and then comes the payload. The fifth penetrator. This isn't a rod. This is a 300 megaton nuclear warhead, the spicy jalapeno of death, diving deep into that freshly carved tunnel. It doesn't detonate on the surface. Surface blasts in space are weak. The vacuum sucks the energy away like a cosmic vacuum cleaner. No, this detonates deep inside the ice. Physics takes over. The warhead triggers. For a microsecond, a small sun is born inside the glacier. The heat vaporizes the ice instantly, turning it into superheated plasma. But the plasma has nowhere to go. It is trapped by millions of tons of ice above it. The pressure spikes to levels usually found in the core of a star. The shockwave can't dissipate into space, so it goes into the comet, It hammers the rock from the inside out. The structure fails. The billions of years old frozen world doesn't just break, it is torn apart. The comet expands violently, shattering into a cloud of gravel and mist. Instead of a bullet to the head of Earth, we get a shotgun blast of sand. The atmosphere absorbs the dust, creating some pretty meteors, but the extinction event is cancelled. And the craziest part? This isn't science fiction. We don't need warp drives or phasers. We have the SLS. We have the tungsten. We have the nukes. Way too many of them, actually. We have the engineering to pull this off today. We don't need to wait for the 23rd century. We just need the will to build the shield before we need it. We have the power to stop the cosmos from hitting the reset button on humanity. So, if you want to make sure you're around to see us punch a comet in the face, you need to smash that subscribe button right now. Like this video to help the algorithm defend the planet, and click that video on your screen right now to dive deeper into the insane engineering that keeps us alive in this hostile universe. Do it now, because the universe isn't waiting for you.